Welcome back, everyone, to our continued discussion on categorical plots. Previously, we learned about the theory behind plots that show you the distribution within categories. In part 2, we're going to focus on creating these plots. Let's head over to a Jupyter Notebook. Alright, here I am at a Jupyter Notebook, and I've already gone ahead and imported NumPy, Pandas, Matplotlib.pyplot, and then Seaborn as SNS. Let's go ahead and read in a new dataset so we can practice on creating visualizations for a wide variety of datasets. So the dataset I'm going to read in is called, we're going to say pd.readcsv, and underneath the Seaborn folder, it is called studentsperformance.csv. And we can check out the head of this data frame to understand what this data is actually representing. Essentially what we have here are every single row is a student, and each of these students took 3 tests, a math test, a reading test, and a writing test, and they were scored on them. And then we have a variety of categorical information on these students. The gender, ethnicity, parental level of education, whether they receive a standard lunch or a free or reduced lunch, and then whether or not they took a test prep course. So what we can do is begin understanding the distributions across the continuous features of the scores and how they relate to various categories. So keep in mind that all of these distributions that we're going to be talking about here, if you really wanted to, you could just see the distribution across everything, for example, the distribution across all the math scores. So what I mean by that is, let's focus on first the box plot. And we're going to tell Seaborn what the source of our data is, which is the DF data frame. And then if I wanted to, I could just say y is equal to math score and not even specify an x. So what happens when you do that is you get to see the box plot distribution for all of the math scores, not separated by any category. And then what we can do is state that we actually do want to separate this by category. For example, maybe I'm interested to see how the distributions compare whether or not you took a test preparation course. So I can say x is equal to test preparation course, run that, and now I can see the differences in distribution. And as always, if you want to edit this figure, right on top of the Seaborn command, you can say plt figure, fig size is equal to, and then if you want, you can edit this to be whatever size you want, so you can just make this larger, and of course if you want to make it a little sharper, you can always expand the DPI. So in general, it looks like these distributions are pretty close, but we also see that if you completed the test preparation course, you're likely to have a higher math score. So you can notice here that the distribution seems to be a little tighter than not having done the test preparation course at all. And you'll notice the median is going to be higher than, again, not having done the test preparation course. And this in general makes sense. We would expect students that have done the test preparation course to perform better on whether it's math score, writing score, etc. So then what we could do is begin exploring this, for example, test prep against the reading score. And so here we can see even more clearly, I should say, that test prep definitely helps narrow that range of scores, as well as just overall range is higher than not having done the test prep. Okay, and recall all the features of the box plot with the whiskers, the median, and then outliers as well. Now, if you want, you could also just check this against not just a binary yes or no, have they done a test prep, but something like the parental level of education. So I can go ahead and copy this and set that to be my x. So now I can see how the parental level of education affects test scores such as the reading score. And if I really wanted to, I could then do subcategories based off another categorical feature, such as the test preparation course. So I can copy that, and the way I do this, and you'll notice this is quite common throughout Seaborn plots, is you simply specify a hue value. And so the hue value, what it does, it essentially creates these subcategories within your larger categories. So here I can see the parental level of education on the x-axis, and then the color hue is representing whether or not, for that particular parental level of education, has the student completed a test preparation course. And you'll notice pretty much for all of these, the median score is higher for people that did complete the test prep course, regardless of the parental level of education. Now, as we mentioned before, sometimes when you're adding in this hue variable, the legend placement by Seaborn is a little annoying. It's covering some information. So what we can always do is use what we know about Matplotlib to say plt dot call legend, and then simply call bbox to anchor argument. So bbox to anchor, and then set this wherever we want, given what we already know about the figure axis or figure canvas lying beneath this. So for example, this would kind of place it over here on the top right, or if I wanted it outside but in the middle, I could place it over here, 0.5. So we already covered this in the Matplotlib section. So just keep that in mind. When you're dealing with hue, Seaborn often puts the legend in an inconvenient spot, so you can always just move it to be outside of the overall figure canvas. And lastly, when we're dealing with box plots, something to keep in mind is if you really want, you can always show this with categories on the y-axis. So notice here, if I switch x equal to reading score and y equal to parental level of education, now I have the box plots shown this way. And again, you can always edit the figure size to however you see fit. So if we want to make this a little taller, for instance, I can set that second dimension to be larger. It really depends on your audience, your visuals, the data source, on which orientation makes sense. As always, your main objective here is to set the data visualization so that the data is being clearly shown and you're not manipulating the visualization in any way to try to say a story that perhaps isn't true. Okay, so those are the box plots. Again, you specify a continuous feature against a categorical one, and if you want, you can have kind of a subcategory based off hue coloring. And as I mentioned before, if you ever want to edit that coloring, you can grab the palette parameter and then set it based off the Matplotlib color maps. So for example, here's set 2. Now, similarly, we can always have a violin plot instead of the box plot. And recall the violin plot is going to show that mirrored KDE that we previously discussed. So what I'm going to do is I'm going to remove hue and test preparation for now. In fact, I'm going to just cut them out. And then let's have reading score versus parental level of education here. And what I'm going to do is switch this from box to violin. And you'll notice it's kind of warning, hey, there was no legend here, which makes sense. We don't have a hue, so we can remove that as well. And here, I'm essentially seeing the same thing I saw last time, but now it's with violin plots. So again, what this is showing is essentially the KDE with kind of this little mini box plot at the center of that violin, this mirrored KDE, for the parental level of education against their reading score. And just like a box plot, I could add in, let me paste back in this hue. So now when you run this, and let's go ahead and have that legend again, you'll notice it will actually show violins plots right next to each other based off hue. And you can probably edit this legend position to be even further out. So we can say something like 1.55 to push it out further. Okay, so is this or is this not a good plot? In my opinion, these violin plots separated by hues are a little harder to compare to one another versus box plots that are right next to each other. So you don't see these violin plots separated by hue too often, but it is possible here. I would prefer that if you do decide to separate based off of hue and have subcategories, that you stick to the box plot. I think the fact that the boxes can touch each other directly and not have kind of this bottom curve touching this top curve makes the box plot more readable for the case where you're going to have a hue separation for a subcategory. That's just my opinion. Obviously, depending on your situation, you may want to deal with that issue. So I did mention that this is kind of an issue. One way we can try to fix this is by setting split equal to true. And so what split does is instead of stacking these together, what it's going to do is make one violin based off the top half of one category and the bottom half of another. So let's see what happens there. Obviously this requires that there's only two categories, but what we're going to say here is say split true. And now you get this really interesting violin plot where essentially we're showing, again, those subcategories of none versus completed. But in this case, because there was only two categories, I could have one half of the violin be none and the other half of the violin be people who completed it. And we can bring this in a little closer, this legend, just so I can make this figure a little larger. But notice again what's happening here, we're basically splitting that up instead of showing the two separate violins. Now, is this an easily readable plot? I don't know. I think, me personally, I'd have a little bit of trouble reading a plot like this, especially, you got to think, most people aren't going to be familiar with the violin plot, so to give them something like this right off the bat, you first have to make sure they understand the violin plot, and then secondly, make sure they understand how you're actually splitting up this data. So, again, in my preference, if you're doing something like this, probably the box plot with the split based off hue is the better way to go. But it always is possible here. The last thing I want to mention is, remember we have this kind of mini box plot in the middle representing those quartiles. You have that little white dot for the median. If you do want, you can get rid of that by just saying here inner is equal to none. And if you run that, it will remove that bar. And there's other options that are in lieu of that little mini box plot bar. Another option for inner is called quartile, which will actually draw lines at those quartiles. So if you run it with quartile is equal to inner, you'll see the quartiles, in this case, for each KDE drawn. So this is a lot of information, and I'm not sure it's really clear. So I would suggest that if you're going to do something like inner quartile, you don't do a separate split based off hue of test preparation course. So for example, let's go ahead and remove this just so we can see clearly what quartile is doing. So now we can remove that legend. It's no longer necessary. And here it's kind of an okay plot. I can see the clear distributions, I can see the quartiles, and if I'm already familiar with the violin plot, maybe this is going to be more informative to me than just a normal box plot. Again, always keep your audience in mind. The last one I want to show you is stick for inner. So if we say here stick is essentially going to draw a line for every instance, kind of showing you the distribution along with this KDE. Now the last thing I want to mention here is recall when we first learned about a KDE plot, there was something called the bandwidth parameter, essentially how much noise you want to pick up when you're stacking and summing together those Gaussian distributions. And one way you can edit that here is with, I'm going to remove inner stick, and what we can do is say BW, and that's the bandwidth argument. So if I were to set bandwidth to something smaller, like 0.1, I run this, notice now these KDEs are going to start picking up more noise. So just as we saw previously when we talked about distributions and just doing the KDE for a single variable or single feature, what you can do is edit the bandwidth for the violins themselves. And obviously the more you increase this, the less of that noise you're picking up. And the smaller it is, the more noise it's going to pick up. So for example, 0.01 is just going to be extremely noisy and definitely not useful. But if you make this too large, they all start looking the same. So this is now really hard to tell what's the difference. So by default, I usually just keep the main bandwidth value that it provides for you. And in general, we can see the main differences in distribution actually based off this box plot, which is another good indicator of whether or not the violin was the best choice. If you're really just looking more at this center white dot and the box inside of it, then really that's just the box plot. I would say then don't bother with the violin. But really interesting plots we can create here. And again, always keep your audience in mind. So let's talk about the advanced plots where they're not super common, but they are available to you. We can have a swarm plot, which is essentially just going to show all the dots for all the entries. So I could say something like SNS swarm plot, and we'll say my data is equal to the data frame or DF. And let's just do it for all the math scores, just so we can check this out, what this looks like. And you'll see here that it will give you a warning, and it says user warning, hey, 15.8% of the points cannot be placed. So essentially the issue here is this figure size or the dot size are not the right size in order to display all the points. So I kind of have two options. I can play around with the dot size, or I can try to expand the figure size. In general, it's easier to just fix the dot size to be something smaller. So if I say size is equal to 2, now the dots are smaller and they fit within my actual plot. And so this is showing kind of a mix between all the points versus a violin plot. So kind of nice here that we do get to see the KDE distribution, but we actually see it now in terms of all the points. It's not a super common plot, so just keep that in mind. And as always, if you want, you can add clarity by editing the figure size. So I can say fig size is equal to, let's say something like 8x4, and then expanding the DPI, which might be necessary if you have a lot of dots on the screen. Keep in mind for really large data sets, a swarm plot is just going to have too many points, and you're going to need to start aggregating with a box plot or a violin plot. And just as before, if you want, you can separate this out based off some categorical column. So if I wanted to, I could separate this out based off, for instance, gender. And now I can see the two swarm plots for the gender and these scores. And the last thing I want to show you with the swarm plot is, in a kind of really interesting move, it actually does support hue. And I want to show you what happens with the hue. So right now what we're going to do is we right now are comparing math score and then the two categories, female versus male. Let's go ahead and now add a hue for the test prep. So let's go ahead and look up what that column was, test preparation course. We're going to grab that, copy it, come back down here, and let's say the hue is test preparation course. We run it, and so what happens is, let's move this legend as well. plt.legend, I'm going to say bbox to anchor, set this outside, say 1.05, 0.5, run that. Okay, maybe that wasn't outside enough. Let's say 3.5, there we go. Okay, so what this has done is it's actually shown you the coloring of the points themselves versus someone who did complete the test prep versus not completing it. Now, in general, this is really hard to read, especially if you're colorblind. You can imagine it's quite difficult to actually make up the differences between which dots are which dots. So this by itself, hue, is not informative with a swarm plot. Instead, what you probably want to do is add in the parameter dodge and set it equal to true. And then what it's going to do is it's going to split up these swarm plots per that secondary hue category that you asked for. Okay, so that's essentially all you need to know about the swarm plot. We really won't use it throughout the course, but it is available to you. You can basically treat it as one of those violin plots, except now it's showing you every single data point. Finally, we did mention this really advanced plot type called the box-in plot. Quite a rare plot because of how new it is, but it is available to you. You just say box-in plot, and then it's essentially treated the same way as a box plot. So I can say math score is y or is x, and then let's say y is, for example, the test preparation course. Copy paste that in, and then remember to say what your data source is, and now you get to see the box plot. And just as before, pretty much has all the same parameters as the normal box plot. So I can say hue, for example, is equal to gender, run that, and now we're seeing the box-in plots, the letter value plots, that is. So sometimes people think this is a little more informative than just a regular box plot, but of course your audience then needs to be educated on what actual box plot or plot type they're viewing. So always keep that in mind. Definitely the most common one you'll see out in the real world is the standard box plot that we discussed earlier. And what's nice is you can always just cut out that N and that E, run this, and you get it in terms of a box plot. So I would kind of encourage you to compare the box plot versus the box-in plot to kind of see the differences between the letter value plot shown here versus the standard box plot. Definitely here we're kind of getting a better idea of the overall distribution. But if you're just interested in that, maybe the violin plot would be the way to go. So lots of options you have here, a lot of them really creative options, and always try your best to show the data as clearly and as simply as possible. Thanks, and I'll see you at the next lecture.